Okay, hello Cloud Gurus and welcome to this lecture. In this lecture we're going to learn about the different routing policies for Route 53, and understanding the different routing policies can be quite important going into the exam because you're going to be thrown a whole bunch of different scenarios and then you'll be asked to choose the best routing policy to fit that scenario. So why don't we start with the different routing policies. So in the last lab you saw where it is we choose the different routing policies, and we had simple, we have weighted, we have latency, we have failover, and we have geolocation. So those are the different routing policies, and I'm going to show you exactly what they do in a second. So simple is the one that we should start with, and it's the one we used in the last lab. So this is the default routing policy when you create a new record set. This is most commonly used when you have a single resource that performs a given function for your domain. For example, one web server that serves contents for the HTTP acloud.guru website, or in our example use aforce.guru. So we use simple because we only had one EC2 instance. It was behind one elastic load balancer, and we kept it very, very simple. Okay, so simple is really simple, forget the pun, but basically if we've got our user and they're trying to make a DNS query, it's going to hit Route 53 and then it's going to be redirected to our EC2 instance. Might go to an elastic load balancer first, but then to our EC2 instance, and this could be in our region US East 1, for example. And the thing to remember about simple routing policies is that there's no intelligence built into it at all, and it is the default routing policy. Now let's move on to weighted. So weighted routing policies lets you split your traffic based on different weights assigned. For example, you can set your 10 or 20% of your traffic to go to US East 1 and 90% or 80% of your traffic to go to US West 1. So what does it look like? Well, we've got our user, they are making a DNS request, it hits Route 53, and Route 53 is then going to split our traffic. So in this example, it's going to send 20% of our traffic over to US East 1, and it's going to send 80% of our traffic over to US West 1. So it's really cool. You can split your traffic across different regions, or you could even split them across different ELBs in the same region, which then have different EC2 instances in different availability zones. And where would you actually use this? Well, apart from splitting your traffic regionally, maybe you're rolling out a new version of your website and you're trying to do some A and B testing. So you want to see whether or not the users like your new website, but you only want to test it on 10% of your user base before you make this your production website. What you would do is you would have weighted routing sending 10% of the user base to the new website, or to an elastic load balancer that sits in front of the different EC2 instances that is hosting the new website, and then you would have Route 53 to send the remainder of your traffic to your existing production website. And that's where people use weighted routing most commonly, is when they're trying to test, do A and B testing. And if you're interested in A and B testing, check out our DevOps professional course. We go into a lot of detail about how to do that. So let's talk a little bit about the next routing policy, which is latency. So latency-based routing allows you to route your traffic based on the lowest network latency for your end user. So basically, it's going to route your traffic to the region that would give them the fastest response time. So to use latency-based routing, basically all you do is you create a latency resource record set for the EC2 or Elastic Load Balancer resource in each region that hosts your website. Now you'll notice that in the last lab I specifically mentioned that I was in Ireland. The thing about Route 53 is that it's global. It's available globally. You don't have to change regions, etc. So if I was to go and create a new elastic load balancer, in the Asia Pacific region, that would be able to be viewed in the Route 53 console. So when you do this, essentially what's happening is Route 53 receives a query for your site, and it's going to select the latency resource record set for the region that gives the user the lowest possible latency. Route 53 will then respond with the value of the associated, or with the values that are associated with that resource record set. So we've got our South African user, for example, and they're doing a DNS request and it's hitting Route 53. And then let's say our latency is 30000 milliseconds or 54 milliseconds for that that DNS request. Route 53 will automatically send our South African user over to EU West 1 because it has a lower latency than if they were to go up to US East 1. So latency-based routing is great for improving your page load times for your different users around the world. And you can set it up in Route 53. You might decide that you want to have an EC2 instance in every single region that AWS has currently, and then set up latency-based routing so that no matter where your users are, whether they're in South Africa or South America or Antarctica, they're always going to get the lowest possible latency. The next routing policy is failover. So failover routing policies are used when you want to create an active-passive setup. For example, you might want your primary site to be in US West 1 and your secondary DR site in US East 1. What happens then is Route 53 is going to monitor the health of your primary site using a health check, and then health checks basically monitor the health of your endpoints. If you then have a failure, let's say you're going to have an availability zone outage, and for some reason all your EC2 instances are in one availability zone, and there's an outage, then Route 53 will fail over to your disaster recovery site. So here we go. We've got our user, they're querying Route 53. We've got our active and our passive sites. Our active site is in US East 1, and our passive site is in US West 1. Suddenly, for some reason, we've lost the US East 1 region. Maybe there was some kind of nuclear war, and your users will then automatically be directed across to US West 1, assuming that it is still there in the event of a nuclear war. So in this example, Route 53 will always send the traffic to EU West 1 because it's detected a failure in US East 1, and I hope to God that never happens. And finally, we have the geolocation routing. So geolocation routing lets you choose where your traffic will be sent based on the geographic location of your users, so from the location which the DNS queries originate. For example, you might want all your queries from Europe to be routed to a fleet of EC2 instances that are specifically configured for your European customers. These servers may have the local language of your European customers installed on it, and all the prices might be displayed in euros. Another example, we've got our European customer. They are making a request to Route 53, and this request is then automatically routed to EU West 1, whereas we have our US-based customers, and we want to send all that traffic over to US East 1. So that's all that geolocation does. It basically is going to send the right traffic to the right location. Okay, so what are my exam tips? Well, remember the different routing policies and their use cases. So we've got simple, we've got weighted, we've got latency, we've got failover, and we've got geolocation. And, it's pretty easy. The hint is always in the name, but you are going to get different scenarios throughout the exam, and they will ask you to choose which is the best routing policy to fit that scenario. So that's it for this lecture, guys. We're not going to have a lab on how to do the different routing policies, for this particular course. We do it in the SysOps Administrator course because it is important to know how to configure that if you're going to be a SysOps administrator. But as a solutions architect, you don't necessarily need to know how to configure it in order to pass the exam. As SysOps administrator, it is really good to be hands-on about it. So if you are interested in that, check out the SysOps Administrator course. We have a different lecture for each of these different routing policies and how to configure them. So if you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you.